I'm going to talk about thermodynamics. Thermodynamics. This is a branch of physics that deals with heat, work, and temperature in relation to energy, entropy, and the physical properties of matter and radiation. The behavior of these quantities is governed by the four laws of thermodynamics, which convey a quantitative description using measurable macroscopic physical quantities, but may be explained in terms of microscopic constituents by statistical mechanics. Thermodynamics applies to a wide variety of topics in science and engineering, especially physical chemistry. Biochemistry. Thermodynamics is the subject of the relation of heat to forces acting between contiguous parts of bodies, and the relation of heat to electrical agency. German physicist and mathematician Rudolf Clausius restated Carnot's principle known as the Carnot cycle and gave to the theory of heat a truer and sounder basis. His most important paper on the moving force of heat, published in 1850, first stated the second law of thermodynamics. In 1875 he introduced the concept of entropy. In 1870 he introduced the virial theorem, which applied to heat, chemical reactions, and has provided the bulk of expansion and knowledge of the field. Other formulations of thermodynamics emerged. Statistical thermodynamics, or statistical mechanics, concerns itself with statistical predictions of the collective motion of particles from their microscopic behavior. Historically, thermodynamics developed out of a desire to increase the efficiency of release steam engines, particularly through the work of French physicist Thierry Carnot. 1824. Engine efficiency was the key that could help France win the Napoleonic Wars. Scots-Irish physicist Lord Kelvin was the first to formulate a concise definition of thermodynamics in 1854, which stated, "Thermodynamics is the subject of the relation of heat to forces acting between contiguous parts of bodies, and the relation of heat to electrical agency." A description of any thermodynamics system employs the four laws of thermodynamics to form an axiomatic basis. The first law specifies that energy can be transferred between physical systems as heat, as work, and with transfer of matter. Second law defines the existence of a quantity called entropy that describes the direction thermodynamically the system can evolve, and entropy is the state of order of a system, and that can be used to quantify the use work that can be extracted from the system. An important concept of thermodynamics is the thermodynamic system, which is a precisely defined region of the universe under study. Everything in the universe except the system is called the surroundings. As the raw law of thermodynamics states, if two systems are in thermal equilibrium with a third, they are also in thermal equilibrium with each other. W denotes the change in the internal energy of a closed system for which heat or work through the system boundary are possible, but matter transfer is not possible. Q denotes the quantity of energy supplied. Q minus W system is heat, and W denotes the amount of thermodynamic work done by the system on its surroundings. Traditional version of the second law of thermodynamics states, heat does not spontaneously flow from a colder body to a hotter body. The second law refers to a system of matter and radiation, initially with inhomogeneities and temperature, pressure, chemical potential, and other intensive properties that are due to internal constraints or impermeable rigid walls within it, or to externally imposed forces. In 1909, Stanton Carathodori presented a purely mathematical approach and an axiomatic formulation description often referred to as geometrical thermodynamics.